Look, I made art. You know what else looks like art? Double replacement reactions. Okay, we're done. Alright, so this is how, in the reaction of Golden Rain, the reason why we ended up with two separate compounds than what we started with. So as an example, I'm going to be using sodium and chlorine. Chlorine has 17 electrons and protons, and then sodium has 7 protons and electrons. And what makes this difference so big is right now they're both odd numbers, and this is essentially, think of it like a magnet, and the electrons are negatively charged and the protons are positively charged, and the magnet kind of, keeps them a little bit away because it's not that mean of a magnet, but he's pulling these guys in and keeping them because he doesn't want to lose them. But these guys on the outside are a little farther from the magnet and the bond isn't as strong. So this guy over here, who has 17, protons in the middle, has a much, higher charge. So what essentially happens is, keep walking across, it's kind of funny. When they get close, they pretty much share these two electrons, and then it results in a multitude of different things, but basically you end up with salt, which is kind of cool that chlorine, mustard gas, also makes salt. But how they share and what happens to it is essentially this, the sodium loses its electron and this one gains an electron, but because this is +1 and this is -1, so this is negatively charged now and this is positively charged, it ends up equaling out to 0, and that's why the substance is neutral and doesn't freak out and doesn't blow up or anything. But you get salt, which is, salt. So, yeah. Alright, so double replacement reactions, they all pretty much fall into this category where they work pretty much the same. It does change depending on what you're using and how much of it you're using, but it pretty much stays in this realm of AB plus CD, and then you mix those together and you end out with AD and CB. And essentially what's happening here is the ionic bonds, they like the A, which represents potassium, likes D, which is nitrate, and then you end out with potassium nitrate. Boom. And then the CB, you get lead iodine, rather than what originally was lead nitrate. And the reason why the potassium nitrate turns into a solid goes into the... Alright, so in this case, what became soluble was nitrate and potassium, and together they form potassium nitrate. They're just written backwards up here. But big rules levels of solubility is actually potassium is part of a little group called the group 1 elements, the group I elements, and NO3 or nitrate is just kind of always soluble in a lot of reactions, and because they're both like so soluble, just under certain pressure and certain circumstances, in which case potassium nitrate, which is formed under the Golden Rain experiment, it is a solid under room temperature, so the IMF, or the intermolecular forces, end up getting stronger. Yeah, and it's pretty interesting to watch potassium nitrate.